Assalamualaikum and greetings to Madam Amalina and friends. Today me and my group mates would like to present about trigonometry.
Assalamualaikum and hello everyone. My name is Muhammad Ashraf bin Abdul Razak. So I am going to talk about the introduction of trigonometry. So trigonometry is widely used in engineering disciplines to determine the sizes and angles of mechanical parts used in various fields. For example, we have civil engineering, electrical engineering or mechanical engineering. Engineers use trigonometry to build structures, design bridges, and also solve scientific problems. For example, electricians use trigonometry in their day-to-day tasks such as bending conduits. Trigonometry is also used in satellite navigation, computer music, which is what we're going to talk about in this presentation, medical imaging, and image compression. So in trigonometry, we have three primary trigonometric functions, which is sine or cosinus, cos, cosinus, tan is for tangent. They are used to calculate the ratios of the sides of a right angle. First one is sinus, or what we call sine. It is equal to the ratio of the length of the opposite side of an angle to the length of the hypotenuse. So here we have hypotenuse as the green one, adjacent as the yellow, and the opposite as the blue color. So for the formula for sinus, if we want to calculate it, we have sin equals to opposite divided by h, or hypotenuse. So for an example, here we have 6 as the hypotenuse, 2 as the adjacent, and 4 for the opposite of the angle. So if we use the formula, which is sine equals to opposite divided by hypotenuse, which is 4 is the opposite of the sine angle, divided by 6 hypotenuse. So we calculate it and then we will get 0.67. So for the second one is cos or cosinus. It is equal to the ratio of the length of the adjacent side to the length of the hypotenuse. So for the formula that we're going to use is CAH, which is CAH. Cos equals to adjacent divided by hypotenuse. Sinus equals to adjacent divided by hypotenuse, which is 2 for the adjacent divided by 6 is the hypotenuse. We calculate it and then we will get 0.2. What is tan or tangent? It is equal to the ratio of the length of the opposite side to the length of the adjacent side. So for the formula that we're using for tan is TOA, TOA. So it is tangent equals to opposite divided by adjacent. An example, we do the opposite of the angle is 4, and then we divide it by the adjacent of the angle, which is 2, and we calculate it and then we will get 2.
My name is Sufiyya binti BAHARULLIZAM, and now I would like to carry on our presentation with the relations of trigonometry in music and production. Without further ado, I would like to explain how the applications are related to trigonometry. Trigonometry plays a significant role in music, especially when it comes to understanding the relationships between musical frequency, harmonics, and the geometry of musical instruments. Here are some ways in which trigonometry is relevant in the context of music. For example, harmonics and overtones, waveforms, sound wave, tuning, instruments design, and sound engineering. Firstly, harmonics and overtones. When a musical instrument produces a sound, it typically generates a fundamental frequency, which is the lowest pitch in the sound. This fundamental frequency is associated with the sine wave, which is trigonometric function. The overtones of harmonics of a musical note are integer multiples of the fundamental frequency. The relationship between these overtones and the fundamental frequency can be described using trigonometric functions, such as sine and cosine wave. Furthermore, musical sound can be represented as a combination of sine waves of a different frequency and amplitudes. This is the basis of Fourier analysis, a mathematical technique that decomposes complex waveforms into their constituent sine waves. Trigonometry is used extensively in understanding the manipulating these waveforms. Moreover, trigonometry is used in the study of sound waves and acoustics, which are crucial for understanding how sound travels and interacts with various structures and surfaces. This knowledge helps in designing concert halls and acoustic space of enhance the quality of music.
Hi, I'm Balqis. So moving on to my point for application of trigonometry in music theory is sound engineering. So in sound engineering, trigonometry is fundamental to understanding and manipulating audio signals such as Fourier transform. So Fourier transform is used to break down complex audio signals into their component frequencies. This is crucial for tasks like equalization and filtering in audio processing. Secondly is spatial audio, where trigonometry is applied to model the spatial positioning of sound sources in 3D space. Moving on to the next application of trigonometry is design and construction of musical instrument. So it also plays a crucial role in designing a musical instrument. For instance, is firstly a string instrument, where trigonometry is used to analyze and understand the vibration of strings on musical instruments like guitars, violins and pianos. Secondly is on harmonics and overtone, where trigonometry helps explain the production of harmonics and overtone in instrument. The relationship between the fundamental frequency and harmonics can be expressed through trigonometric concept. Last point of application of trigonometry in music theory is process of tuning musical instrument. So trigonometry helps us to understand the relationship between harmonics and intervals, guiding the tuning process in order for us to achieve accurate sound. For instance, equal temperament tuning, where the frequency ratios between the adjacent notes are based on specific mathematical ratios. Lastly is instrument-specific tuning, where trigonometry is applied to calculate the optimal length and tension of strings on instruments. This calculation helps us achieve the desired pitch for each string.
Hello guys, my name is SHAARANGIN Shankar. So for now I would like to talk about the mathematical solution with drawings, but before that I would like to giving you guys a little touch on what are the types of graphs for trigonometric functions. Okay, so there are three types of them. First will be sine graph, then second will be cosine graph, and the third one will be tangent graph. So hope you guys are looking at the screen. So if you look at the sine graph and cosine graph, if you compare with them, there's no much differences between them. They have more similarities. But if you look at tangent graph, it's completely different. Okay, it's completely different because the function is in between the positive infinity number and negative infinity number. So if you look at the graph, the line will be like never ending. Okay, so there's no stop, there's no end for that. It's not going to stop. So because it's infinity. So these are the basic things you have to know before you construct or sketch a graph for trigonometric function. Each graph has, each type has each shape. Okay, so you have to remember it before you do a question. So now let's hop into the mathematical solution. So yeah, so hello guys, we have come to our topic. So I don't have any script or what, I'm not holding. If I look down or up like that, I'm not looking at a script, I'm just looking at my question only. So the question I already give in the slide, so you can check it out. So the question is y equals to 2 sine x plus 1. So you have to, before you sketch the graph, you have to analyze the question. There are four main rules. First of all, the type of the graph. Is it a sine graph? Is it a cosine graph? Or is it a tangent graph? Okay, second will be the amplitude of the graph, the maximum point and the minimum point of the graph. Okay, the third will be the number of cycle or number of shape, you can call it. So is it 1, 2, 3? It depends on the question. And the fourth rule is the vertical shift. Is it increasing? Is the minimum point or the maximum point are increasing? The amplitude is increasing or decreasing? So it depends on the question. Okay, so already labeled in each rule has its own color, so you guys can look it out easily, you can refer it easily. So let's go into the question. So y equals to 2 sine x plus 1. As I said before, what type of graph is this? Sorry, can't hear you. Yeah, it's a sine graph. Okay, it's a sine graph. Okay, yo, focus at me. Yeah, look at me. Okay, just focus. Yeah, sine graph. So it shouldn't be a problem. It will be easy. So second rule is the amplitude. The maximum point and minimum point is 2. Okay, where you see is the number before the sine x. Okay, that's the amplitude for us. So it's between 2 and -2. So the graph must be between that range. Okay, the third rule is the number of shape or number of cycle, can call it. It's 1. How you know? Because sine x, you know, the variable after the x, after the sine, sorry, the variable after the sine is x. So x refers to 1. So it's 1. It's a 1 number of shape lah. Just 1 drawing. Okay, so shouldn't be a problem. And then the vertical shift, we have to wait first. So if you see in the slide, there will be 2 drawings. One will be in the dotted line blue color, one will be in the red color. So the red color, you don't have to focus first. Focus on the blue one. Okay, you look at it. The amplitude is between 2 and -2. Okay, so it's a sine graph. So everything is completely done in the blue color. But the difference between the red color and blue color is the red color is a vertical shift one. So you have to plus 1. If 0 means from 0, you have to plus 1. You have to increase the graph. So from -2, you have to plus 1 and you have to go to -1. So the range will be to 3 to -1. The graph should be in between 3 to -1 because of the vertical shift. If you look at the question, y equals to sine x plus 1. The plus 1 is the vertical shift. So if you give the answer in the blue color, the dotted line, if you give the answer in that, that's a wrong answer. Okay, the red color is the correct answer. Okay, so
Conclusion, trigonometry in music theory is crucial for unraveling the geometric patterns of sound waves. This proves that trigonometry is helping us to understand the rhythmic and harmonic dimensions of music through mathematical relationship and angles.
So this is our end of the presentation. I'm the pirate guy if you are looking in the screen. If you have any question, please do drop it on the comment section down below. Thank you for watching and please don't forget to subscribe and like it. And don't forget to share it.